We know that in all languages, alphabets combine to give words. The language of chemistry starts with the symbols. So what happens when these symbols combine? When these symbols combine, we get the chemical formulae. Let's see how we get these chemical formulae. Recall some elements which have positive valencies. So hydrogen has a valency +1, sodium +1, and so on. Similarly, recall some elements with negative valencies. So hydrogen in this case has -1. We'll see this. Chlorine -1, bromine -1, and so on. So these are the elements with positive valencies. These are the elements with negative valencies. In this case, you'll observe that hydrogen is showing both positive valency and negative valency. Similarly, carbon. It shows both positive valency and negative valency. We know that carbon has 4 electrons in its valence shell. So it can neither gain electrons nor lose electrons. It shares electrons. So that is why we consider both +4 valency for carbon and -4 valency for carbon. Now in which case we take +4 and in which case we take -4, we'll see that. Similarly, hydrogen, it completes its duplet structure by sharing 1 electron. So it shows both positive and negative valency. So in which case we take +1 and -1, we'll see that. Water, it's a compound of hydrogen and oxygen. Hydrogen has 1 valence electron and oxygen has 6 valence electrons. Now, in order to complete its duplet structure and its octet structure, hydrogen shares electrons with the oxygen atom. So now hydrogen shares 1 electron. So you'll see that hydrogen now has a duplet structure, which is the stable form for hydrogen. But if we count the number of valence electrons in oxygen now, we have 1, 2, 3, 4, 5, 6, 7. So now oxygen is not satisfying the octet rule. So it's not stable. So in order to become stable, oxygen needs 1 more electron. So how does it do that? It uses 1 more hydrogen atom. So now 1 more hydrogen atom shares its electron with the oxygen atom. So both hydrogen atoms now have a duplet structure. So both are stable. And oxygen atom now has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So octet is satisfied for the oxygen atom. So now all the 3 are stable. So this is the structure for water, which is represented as H2. So we have 2 hydrogen atoms. So we write 2 as the subscript. We have 1 oxygen atom. So we can ignore that subscript 1. So we simply write the symbol for oxygen, which is O. So this is a water molecule. Now it's not very easy to write these atoms again and again to get the chemical formula. So this is a chemical formula. How? We have a symbol of hydrogen. We have a symbol of oxygen. So when these chemical symbols combine, we get a chemical formula. So it's not always easy to write the atomic forms. So how do we get these chemical formulae? Let's see. So start by writing the element names. So we have hydrogen. The symbol for hydrogen is capital H. We write oxygen. The symbol for oxygen is capital O. Now write these 2 symbols next to one another with some little space in between. Next, check their valencies. So the valency for oxygen is -2 and hydrogen shows both +1 valency and -1 valency. So when we are writing a chemical formula, we always need 1 positive ion and 1 negative ion. Since oxygen shows only 1 valency, which is -2, so we have to take the positive valency for hydrogen, which is +1. So we write the valencies. The valency for hydrogen +1, valency for oxygen -2. So now write their valencies on top as the superscripts. So initially we had written the symbols. Now write the valencies on top. Next, ignore the signs. So just write the numbers. Now interchange these numbers. Write the symbols again. The superscript in this case, make it the subscript on interchanging. The superscript in this case, make it the subscript over here. So write the valencies on top, ignore the signs, interchange the numbers and make the superscripts as subscripts. So what do you get? We can ignore this 1. So we get H2O. So as we got earlier, so this shows 2 atoms of hydrogen atom and 1 atom of oxygen. So this is the chemical formula for water. So when symbols combine, we get the chemical formula. So in the language of chemistry, the chemical symbols combine to give the chemical formula. So let's solve a question here. We have a compound of magnesium and chlorine. This compound is a white colored powder. So valency of magnesium is +2 and that of chlorine is -1. So what's the formula of this compound? Let's see. So if we write them in the atomic forms, so this is the atomic structure for magnesium atom. Its electronic configuration is 282. The electronic configuration for each chlorine atom is 287. So as you will see, magnesium has 2 extra electrons. So in order to complete its octet, it needs to lose these 2 electrons. And in order to complete its octet, both the chlorine atoms have to gain 1 electron. So now the magnesium atom gives 1 electron to 1 chlorine atom. It gives another valence electron to another chlorine atom. So by doing this, the 3 of them have octet satisfied. So the 3 of them have stable structures. So we get Mg, since there is 1 atom of magnesium, and Cl2. This is because there are 2 atoms of chlorine. So this is the chemical formula of the compound formed by magnesium and chlorine. But again, it's not easy to write all these atomic structures again and again. So how do we write the chemical formula? As we've seen before, we write the element names, then write the symbols. So the symbol for magnesium is Mg, symbol for chlorine is Cl. So write these 2 symbols next to one another. Check the valencies. So the valency of magnesium is +2. Valency of chlorine is -1. So now we'll write the valencies. Valency of magnesium is +2. Valency of chlorine is -1. So we write these as superscripts. And in the next step, we exchange these valencies. So we write the valencies, ignore the signs. Make the superscript as subscript. And in this case, make the superscript as subscript. So now we can ignore this number 1. So we get MgCl2. So this is the chemical formula of the compound formed by magnesium and chlorine. Initially, we had formed water, that is H2O. So you must be wondering why we write hydrogen first and why are we writing magnesium in this case first. So always remember, we write the positive ion before the negative ion. In this case, magnesium had a positive valency, chlorine had the negative valency, so we write magnesium before chlorine. Similarly, in case of water, hydrogen showed a positive valency, oxygen showed a negative valency. So we always write the positive ion before the negative ion. This is another compound, a compound of calcium and oxygen. This is a major constituent in the formation of cement. So let's try to find its formula. So if we write the atomic structures, this is an atom of calcium, this is an atom of oxygen. The electronic configuration of calcium is 2882. So you observe it has 2 extra electrons. so it loses these 2 electrons to complete its octet. Similarly, oxygen needs 2 electrons to complete its octet. So calcium gives these 2 valence electrons to oxygen. Now both of them have stable octet structure, and so their formula is CaO. Since both have only one atom each, so we ignore the one subscripts in this case, so we get the formula as CaO. Now let's write the formula by the way that we've just seen. So we write the element names, calcium, oxygen. Their symbols, calcium symbol is Ca, the symbol for oxygen is O. So write these 2 symbols. Now check their valencies. This valency of calcium is +2. Valency of oxygen is -2. We write the positive ion before the negative ion. So we write the valencies, and now calcium is the positive ion, oxygen is the negative ion. So we write calcium before oxygen, and in the next step we interchange the valencies. So we ignore the signs. So we make the superscript as the subscript, and we make the superscript as subscript. So we get the formula which is Ca2O2. Now this shows there are 2 atoms of calcium and 2 atoms of oxygen. But when we wrote the atomic structure, we saw that there was only 1 atom of calcium and 1 atom of oxygen. So does this mean that the formula Ca2O2, which we right now got, is wrong? How do we solve this discrepancy? We solve this discrepancy by taking the HCF. HCF, you know, is the highest common factor. So when you get Ca2O2, we take the HCF of these 2 subscripts. So HCF of 2 and 2 is the HCF of 2 and 2 is 2. So divide each number by 2. So when you divide this by 2, you get 1. When you divide this 2 by 2, you get 1. So in order to write the formula, you write Ca, and since you have 1, we can ignore the 1 in the subscript. And now when you divide this 2 by 2, again you get 1. So we get CaO. So this is the formula of calcium, of the compound formed by calcium and oxygen. So whenever we are getting a subscript, we always calculate the HCF of the subscripts. We divide these numbers by the highest common factor, and then we get the number of atoms which are present in the compound. So when we received Ca2O2, which shows there are 2 atoms of calcium and 2 atoms of oxygen, this is wrong, because as we had seen from the atomic structures, there is only 1 atom of calcium and 1 atom of oxygen. So in order to solve the discrepancy, we take the highest common factor, divide each number by the highest common factor, and then we get the number of atoms which are present in the compound. Carbon dioxide, we know, is the gas emitted by chimneys, and that is also the gas which is used by trees and plants for photosynthesis, and carbon dioxide is the gas that we exhale out. So what is the formula of carbon dioxide? So if we see the atomic structures, we are showing only the valence shell for these atoms. So the valence shell of carbon has 4 valence electrons. Valence shell of each oxygen atom has 6 valence electrons. So in order to complete their octet, it shares electrons. So now carbon shares 2 electrons with oxygen. So each oxygen atom has 1, 2, 3, 4, 5, 6, 7, 8 electrons. And each carbon atom, in this case we have only 1 carbon atom, it has 1, 2, 3, 4, 5, 6, 7, 8. So both carbon and the oxygen atoms, they have satisfied the octet rule, so they are all stable. So the formula of the compound formed by carbon and oxygen, which is the carbon dioxide gas, is CO2. This shows there is only 1 atom of carbon and there are 2 atoms of oxygen. Now let's try to find its formula by the other method. So we write the element names, their symbols. So write the symbols next to each other. Check their valencies. So the valency of oxygen is -2. Valency of carbon is both +4 and -4. We know that while writing the formulae, we need one positive ion and one negative ion. So which valency do we take in this case? We take +4. So now we write their valencies. So valency of carbon is +4. Valency of oxygen is -2. So we get carbon +4, oxygen -2. So now when we interchange the valencies, this superscript becomes the subscript and this superscript becomes the subscript. So we get C2O4. But is this the formula of carbon dioxide? We know it's not. So what do? We take the HCF. So when we take the HCF of 2 and 4, we get that the HCF is 2. So when you divide this 2 by 2, you get 1. And when you divide this 4 by 2, you get 2. So now the formula becomes C1. We can ignore this one. And O2. So the formula of carbon dioxide gas which we have received is CO2. So we always take the highest common factor. We divide the subscripts by the highest common factor, and this is how we derive the final formula of the compound. So the formula of the compound, which is formed by the two elements, magnesium and nitrogen, should be, we are given the valencies of both magnesium, which is +2, and that of nitrogen is -3. So what should be its formula? So what do? We write the element names, and the symbols. So the symbol for magnesium is Mg, and for nitrogen it's N. The valencies are already given. We know that the valency of magnesium is +2, and of nitrogen it's -3. Now we'll interchange the valencies. So we have Mg 2, nitrogen 3, this superscript becomes the subscript, and this superscript becomes the subscript. So we get Mg 3N2. Now if we take the HCF of 3 and 2, what will we get? The highest common factor of 3 and 2 is 1. So when we divide 3 by 1, we get 3. When we divide 2 by 1, we get 2. So the formula does not change. So the formula of the compound formed by magnesium and nitrogen is Mg3N2. This shows there are 3 atoms of magnesium, 2 atoms of nitrogen, and the positive ion is always written before the negative ion. So this is how we get the chemical formulae, which are a combination of the chemical symbols.